all. I hope you all are fine. So today our topic is Rolle's law. This is the topic of class 12th unit 1st. In this session we will discuss about Rolle's law for volatile solute as well as for non-volatile solutes. Okay, students. So what do you mean by volatile and non-volatile? Volatile substances are those which can convert into the vapors very easily. And non-volatiles, they cannot be converted into the vapors. Okay. This is known as Rolle's law because it was given by the Mary Rolles. So now we will discuss what does this law says. Rolle's law for volatile solutes. According to the Rolle's law, for any volatile substance, the partial pressure exerted by vapor or gas on surface of liquid is directly proportional to the mole fraction. Means partial pressure of a gas is directly proportional to the mole fraction of that in liquid or in solution. Let us consider we have solute A. Here it is volatile in nature, means it exerts some vapors on the surface of liquid. It is solute. Solute is that which is dissolved in solution. Okay. And this is the solvent B. It is also volatile in nature. It is solvent, means in which solute is dissolved. So students, this is solute A. It is volatile, so it exerts some vapors, and these vapors exert pressure on surface of the liquid. Let us consider they are exerting pressure P naught A. And here solvent B it is also volatile in nature. So molecules of this also exert some pressure on the surface. Let us consider they are exerting pressure P naught B. If I add XA mole fraction of solute in this beaker and XB mole fraction of solvent. So now in this beaker, molecules of both solute as well as solvent are present. So both are exerting pressure on the surface of liquid. So now, which pressure is exerted by the molecules of A? That is known as partial pressure of A. And which is exerted by the molecules of B? That is known as the partial pressure of the B. According to the Rolle's law, this partial pressure is directly proportional to the mole fraction of that component. So here mole fraction of A is added into this solution is XA. So here PA is directly proportional to the XA. Now PA is equal to, now we will put constant of proportionality, and in pure state they exert the constant pressure, so we can take the P naught A as constant of the proportionality. So PA is equal to P naught A x A. Consider this is the equation first. And for solvent, here partial pressure is Pb. So Pb directly proportional to the mole fraction of B, and mole fraction of B is Xb. So Pb directly proportional to the B. Again Pb is equal to, now write constant of proportionality for that. So constant of proportionality we can take here P naught B. Yes, we can take P naught B. So P naught B x B. Let us consider this is the equation 2. Okay, so here total pressure PT is equal to the pressure exerted by A plus pressure exerted by B. So PT is equal to PA plus PB. Okay students, so how can we write PT? Here PT is equal to PA plus PB. According to the equation first, PA is equal to P naught A XA. So put the value P naught A XA plus value of PB according to the equation second. PB is equal to P naught B XB. Okay students, so let us consider P naught A greater than P naught B. And we know very well total mole fraction of a solution is always 1. So here total mole fraction is XA plus XB is equal to 1. Here we can write XB is equal to 1 minus XA. So from here PT is equal to P naught A XA plus P naught B. We can put the value of XB, and value of XB is 1 minus XA. Here P naught A XA, now P naught A into 1, P naught B into 1 is equal to P naught B minus P naught B into XA, P naught B XA. So students, our first equation was PA is equal to P naught A XA. Second equation was P naught B. PB is equal to P naught B XB. And PT is total pressure. It is PA plus PB. And it is P naught, put value P naught A XA plus put value of PB P naught B XB. Here value of XB, it is 1 minus XA. Why it is? Because total mole fraction XA plus XB of any solution is always 1. So from here XB is equal to 1 minus XA. Now P naught A XA plus P naught B, now multiply it by XA, so P naught B XA. Again P naught A XA, and we can write this term also with this one, P naught B XA plus P naught B. In these terms XA is common, so now take XA is common. From here P naught A, and from here we have P naught B plus P naught B. Okay, student. So we have this equation for P total. Consider this is the equation third. So we will draw graph for roll flow with help of these three equations. Students, according to equation first, this is PA is equal to P naught A XA. This can be written in this way, y is equal to mx. This is the equation of straight line. So at y-axis we will take partial pressure and at x-axis we will take mole fraction. So we can draw the graph. At y-axis, we will take partial pressure of A, and at x-axis, we will take mole fraction. Okay, students. So, according to the equation, if XA is maximum, mole fraction of solute is maximum. If XA is 1, so PA is equal to P naught A into 1. So PA is equal to P naught A. And if XA is 0, if we take value of XA is 0, then total partial pressure of A will also 0. Okay, student. So here we can take value of XA is 1 for value XA. What is the value of partial pressure? It is P naught A. And at value 0, where it will be 0? We know very well total mole fraction XA plus XB will be 1. Because here XA is 1 means XB is equal to 0. And if XA is 0 means XB will be 1. So let us consider at this point XB is maximum, it is 1. So here we can take XA is 0. So students, here slope is positive. What is the slope? P naught A. And this is the equation of the straight line. So this will be the graph for PA. Here PA is equal to P naught A X A. In same way, we can draw the graph for PB for equation 2. Again, it is equation of the straight line y is equal to mx. Here at y-axis we will take PB. Let us consider P naught A greater than P naught B. So let us consider it is PB. Okay. It is PB. And if XB is equal to 1, again PB is equal to P naught B. So at this point PB is equal to P naught B. Here XA is equal to 1 means XB is equal to 0. Okay, so it is straight line. Now graph will be in this way. So this is the graph for PB. PB is equal to P naught B XB. With help of equation third, we will draw graph for PT, total pressure. Here XA, put value of XA is 0. If XA is 0, so this total term is also 0. So PT is equal to P naught B. So we can see from here, if XA is equal to 0, so value of PT is P naught B. And if value of XA is equal to 1, okay, so XA is equal to 1, then PT is equal to P naught A minus P naught B plus P naught B. P naught B plus minus, they cancel each other, so PT will be equal to the P naught A. So for XA is equal to 1, what is the value of the PT? It is P naught A. Now join both these 2 points. So this is the graph for PT, total pressure. It is equal to PA plus PB. Okay, student. So this is the Rolle's law for volatile liquids, for volatile solutes. Now we will discuss Rolle's law for non-volatile solutes. If solute is non-volatile, if solute is non-volatile, means solute is not exerting, it is not producing vapors. And here we will take solvent is volatile. Means it is exerting vapors. Let us consider, students, this is a pure solvent A. Here molecules of solvent are producing vapors. So these vapors will exert pressure on surface of this liquid. Let us consider this pressure is P naught A. But if we add some solute, that is XB. Let us consider we are adding some molecule of solute, but these are not producing the vapors, but they are affecting the pressure of the solvent, because some molecules of the solutes are also present at the surface of the liquid. So they decrease the vapor pressure. Now here vapor pressure will be PA. Here vapor pressure will be PA, or according to the Rolle's law, PA is equal to P naught A X A. Okay, students. Now we can calculate del P. Del P means change in pressure. Okay, so it is the pressure in pure state P naught A minus partial pressure after adding solute P A. Here put value of PA, P naught A minus PA is P naught A X A is equal to P naught A minus P naught A, put value of XA. So we know very well again, total mole fraction is 1. So from here, XA we can write 1 minus XB. 1 minus XB. From here, delta P is equal to P naught A minus P naught A XB. Okay, students. So from here, P naught A minus PA, that is delta P, and it is known as lowering of vapor pressure. Lowering of vapor pressure. Okay, student. And after solving this, we get P naught A minus PA by P naught A is equal to XB. This is known as relative lowering of the vapor pressure. Means vapor pressure of any solvent is affected by the solute present in it. And this relative lowering of vapor pressure is also a colligative property. Colligative property we will discuss in next session. Thank you. Have a nice day.